Angular momentum is a conserved quantity. That means that as long as no outside force is acting on a system, the angular momentum that it has will stay the same. The angular momentum depends on three things. It depends on the mass of the system, it depends on the rate of spin of the system, how fast it's going around, and it depends on how the mass is distributed within the system. So I'm going to demonstrate the way that the angular momentum depends on some of these quantities using this special low friction platform that we call the rotating platform of doom. Okay, so I gave myself just a little bit of a kick. I can feel myself spinning ever so slightly. So here I'm going around. I can push myself around against the friction, but I have to work really hard in order to get going against the friction that's in the platform, even though it's a low friction platform. So now I'm going to go ahead and I'm going to change some of those things that I was talking about. So I'm going to have Michelle go ahead and give me a little push to send me spinning a little faster. And now I have my mass distributed, so there's a lot of it toward the outside. My arms are out away from my body. What's going to happen if I change that distribution so that I bring my arms in toward my body? Well, you've seen ice skaters, so you should have an idea of what will happen. I should spin faster. So let me try it and see. Michelle, go ahead and give me another little push to get me going. And now I'll bring my arms in and I spin faster. And I push my arms out and I spin more slowly. And I bring them in and I spin faster and I push them out and I go more slowly. What I can do is I can go ahead and increase the amount of mass that's way out here at the outside. So now I have a lot more mass. So now I'm spinning even more slowly than I was before. And if I go ahead and ask Michelle to give me a little push, okay, I'm spinning again. Now we should see a bigger effect when I bring this mass in. And we do. I spin a lot faster than I did before. And now I put the mass back out again, and I spin even more slowly, and I bring them in and I go fast. So the important thing to remember about angular momentum is that there are three things that matter. There's the mass, the rate at which the object spins, and how the mass is distributed. And if you change any one of those, one of the other two has to change as well in order that angular momentum is conserved.